So, when I started in the fountain business, I originally came from the automation world and the heavy process automation world, metal smelting, uh, oil refineries, these sort of things. And when I found myself in the fountain world somewhat by accident, I started seeing all of these opportunities to improve the technology that existed at that time. And that's what the splash valve is I wanted to make something that was easy to take care of and basically never broke, right? And I also wanted to make it as clog free as possible, speaking to the fluid dynamics. So the spool within the splash valve is a full open bore valve. So if you were to have the valve at full open, right, you can actually push a 1-inch broom handle through the valve. And so it has almost no places to clog, right? We have no seals internally, so nothing to wear out. And that also allows us to avoid any clogs that might hang on a seal, or some designs might try to use like a wiper blade or something like that. We don't do any of that. We rely on a very small tortured path seal, right? And the way that the fluid dynamics work, as I mentioned earlier, is we never stop the water, we only change its direction. So that's how we can proportionally can drive it to the nozzle or to the bypass or anywhere in between. And because we're captured with the pressure plug, the pressure applied by the pump is equal on all sides of the spool, all around its diameter and each end. So the water doesn't actually apply any torque to the spool, the rotating spool, because the pressure is equalized all the way around. And that allows our very efficient actuator to rotate that no matter, if you're running at a very low flow rate, maybe your nozzle's only going 7 feet, or at a higher flow rate where your nozzle's going 60 or 70 feet.